Welcome to the world of Multicast. In this video, we'll explore the fascinating realm of IPv4 PIM, Protocol-Independent Multicast, diving deep into its functionalities and troubleshooting common issues. But before we get technical, let's make things interesting with some fun analogies. PIM modes. Imagine a bustling city with several neighborhoods, IP subnets. Residents, data packets, need to reach specific groups of people, multicast groups for events or announcements. Here's how PIM modes handle these deliveries. Dense mode, the town crier. A town crier, RP rendezvous point, broadcasts announcements, multicast datagrams to everyone, all devices, in the neighborhood. This is efficient for large groups, but can get noisy for smaller ones. Sparse mode, the targeted delivery service. A delivery service picks up announcements, multicast datagrams, only for specific groups, multicast groups, and delivers them directly to interested residents, devices. This is ideal for smaller, targeted audiences, but requires more coordination. Sparse dense mode, the hybrid approach. The town crier RP handles large groups, while the delivery service takes care of smaller, targeted ones. This combines the efficiency of dense mode for large audiences with the precision of sparse mode for smaller groups. Delegation of duties, static RP, auto RP, and BSR. Let's say the town needs to appoint someone to manage announcements. Here's how PIM handles this responsibility. Static RP, the pre-appointed leader. The town council explicitly chooses a leader, static RP, to manage announcements. This ensures a clear chain of command, but requires manual configuration. Auto RP, the volunteer system. Residents, routers can volunteer to become the RP based on predefined rules. This provides flexibility, but could lead to conflicts if multiple routers compete for the role. BSR, bootstrap router, the backup system. If the chosen RP, static or auto-selected, becomes unavailable, a backup leader, BSR, steps in to keep things running smoothly. This ensures redundancy and avoids disruptions. Bidirectional PIM, two-way traffic on the information highway. Imagine a two-lane highway for announcements. Data can flow in both directions. Bidirectional PIM, the two-way highway. This mode allows multicast traffic to flow not just from sources to receivers, but also from receivers back to sources, e.g. for acknowledgements. Think of it as a two-way conversation instead of a one-way broadcast. Source-specific multicast, tailoring the message. In our town, some announcements are specific to certain sources, e.g. the mayor versus the local bakery. Here's how PIM handles this. Source-specific multicast, the targeted source. Devices only join multicast groups for specific sources, e.g. only listen to the mayor's announcements, not the bakery's. This reduces unnecessary traffic and improves efficiency. Group to RP mapping, finding the right leader. Imagine a complex network with multiple towns, IP subnets, and leaders, RPs. Residents, data packets, need to know which leader to contact for specific groups. Group to RP mapping, the town directory. A directory, group to RP mapping, tells residents which leader, RP, is responsible for announcements for each group, multicast group across different towns, IP subnets. This ensures data packets reach the right leader for efficient delivery. Multicast boundary, keeping traffic flowing smoothly. Imagine a river separating two towns, IP subnets. We need a bridge, multicast boundary, to allow announcements to flow across. Multicast boundary, the bridge, a designated router, multicast boundary router, acts as a bridge, allowing multicast traffic to flow between different IP subnets while controlling its spread. This prevents unnecessary information overload in different parts of the network. Moving beyond analogies, troubleshooting, and implementation. Now that you have a clear understanding of these PIM concepts with fun analogies, we'll delve into the practical aspects of implementation and troubleshooting these functionalities in your network. We'll explore configuration steps, common issues, and debugging techniques to ensure your multicast environment functions smoothly. Intra-domain MSDP, the Anycast mailbox. Imagine a large apartment complex, IP domain, where residents' devices can leave or pick up multicast messages, datagrams, from a central mailbox, Anycast RP managed by the mail carrier, MSDP. This mailbox is always accessible, regardless of the specific mail carrier.